Okay, so for page 679 of your interactive notebook, you're going to title it Linear versus Exponential Growth. You have a sheet that looks like this. If you'll cut it out, it's going to be pasted on there. And so we are going to be looking at two different plans, Plan 1 and Plan 2, to illustrate the difference between those two growths, linear versus exponential. And the prompt says, you've been thinking about ways to earn money for the holidays coming up, to buy others gifts, not for yourself, of course, and you have to decide which plan to choose. So under Plan 1, you do chores around the house, and each day that you do this, after it's completed, your parents give you $1, and that's going to last for 2 weeks. Plan 2, you are going to be given 1 penny every single day for 14 days. So on day 1, you're going to be given 1 penny, but then on day 2, it's actually going to double that, and you're going to get 2 pennies. On day 3, it's going to double that, and you're going to get 4 pennies. And then on day 4, you're going to get double of that, which is 8 pennies, and then so forth. And again, this is going to last for 14 days or 2 weeks. And so your job now is to decide which plan would be best in order to make the most amount of money. So we're going to start by looking at this as a table. So under Plan 1 and Plan 2, we're going to go ahead and in our table set up our XY. X is going to represent what day you're doing your chore, and then Y is going to represent the total amount of money you have after each day that you complete your chores. So when you go to fill in these tables, for each day you get another $1 under Plan 1. So for day 1 you'll get $1. Day 2 you'll get another $1, but you now have a total of $2. On day 3 you'll get another $1, but you now have a total of $3, and then so forth. In Plan 2, for day 1 you only get 1 penny. On day 2 you get 2 pennies, but you already had 1 penny from the day before, so you now have a total of 3 pennies. In day 3, you're going to get a total of 4 pennies. However, you already had 3 pennies from the day before, so you're going to add that and you now have 7 pennies. And then day 4, you'll get 8 cents. And then if you add that to the 7 pennies that you already got from the previous 3 days, you'll have a total of 15 cents. So go ahead and pause the video and continue this same process to fill in the rest of your table for your Plan 2. And so now, if we go to graph both of these, pause the video first to graph each. And then when you do that, you'll notice that on Plan 1, you have a straight line that has a constant slope because you're getting $1 every single day. On Plan 2, you have a curved line. And so in this case, it is not going to be constant as a result of you getting a different amount every single day. Now, if we look at that in terms of what's happening for each day, so for example, in this first plan, from day 1 to day 2, it doesn't matter if you go between day 1 and day 2, or day 5 and day 6, or day 9 and day 10, or day 13 and 14. For every single day, you get another $1, so you're just simply adding 1 to the previous day. For Plan 2, however, if you look at day 1, you started off with 1 cent. On day 2, you got 2 additional cents, so you doubled that amount, but now you add that to the amount you already have, you now have a total of 3 cents. Under day 3, so from day 2 to day 3, you now have, from day 1 to day 2, you now get an additional 2 cents, but that was double from the day before, so now you have a total of 3 cents. I think I may have just repeated myself, sorry. Now from day 2 to day 3, you take that 2 cent total that you got from day 2, and you double it. You now are going to get 4 cents, so you're going to add that to your previous day, and you're going to get a total of 7 cent now, and you're adding 4 cent. So if you continue this pattern from day 2 to day 3 to day 4, you now have 8 cent being added to your 7 cent. So you doubled your 4 cent and you added it. And then from day 4 to day 5, you now have 16 cent. So looking at this same pattern from day 1 to day 14, you'll notice that you're taking the change, the amount of extra money that you're getting from day to day, is doubling the amount that you got from the previous day. So when you get to the end here, for example, from day 9 to day 10, you're getting $5.12 between the 2 days. But then from day 13 to day 14, you're actually getting a total of $81.92 being added. So you'll notice that the rate of change is actually significantly different from day to day. Once you get past that threshold of like maybe day 10, day 11, and so forth, the numbers are increasing significantly faster. So in this first plan, you'll notice that you have a straight line. This is indicating that you have a constant rate of change. The rate of change is how much money you add on each day. And so in this case, it's the same number, adding on 1, adding on 1, adding on 1. In this next one, however, it's that the amount that you're adding on is different from day to day. The first, at the very beginning, it's very, very flat because you're only adding on 2 cent or 4 cent or 8 cent. However, as the days go past, it's significantly increasing how much you're adding. So now you're adding, for example, $20 or $40 or $82 and so forth. So the line is becoming much steeper, whereas it started off very flat toward the beginning. So now if we look at this in terms of an equation, in this first one, because this is a line, we have y equals mx plus b, where m is going to be your slope. This is your constant rate of change, and your b is going to be how much you are going to start off with on day 0, your initial earnings. And so when you go to plug this in, you end up with y equals mx plus b. M is going to be 1 and b is going to be 0, so we end up with y equals x. In this next one, however, this one's a little bit different. You have to pay attention to this. So the number that we're adding on each time, not the new number, not the numbers in red, the numbers in green, the number that you're adding on each time is doubling from the day before. So first of all, that's going to be part of my equation, 2 to the x, because I'm doubling it. That's the number that I'm multiplying from day to day. And so now you have an equation that you're going to start off with. This is going to be exponential, so you have 2 to the x so far. Well, the thing that you were doubling every single time that you began with was that 1 penny. And so this a then is going to be representative of your 1 penny that you're doubling from day to day. Now, this is where it gets a little bit weird. On day 1, if you plug in x equals 1 right now, it's going to say 2 to the 1, which is 2, times 0.01, which is 0.02. So it's saying that on day 1 you have 2 pennies or 2 cent, but that is incorrect. On day 1 you actually only have 1 penny. And then let's say, for example, let's look at 4, the 4th day, x equals 4. So on the 4th day, you're going to plug in x equals 4, and you get 2 to the 16. And so if you multiply that by 0.01, you're going to get 0.16. So on day 4, according to this equation, you have a total of 16 cents. But again, that is also incorrect. You only have 15 cents. So in both of those situations, you'll notice that we are off by a penny. And so my final equation then has to subtract 1 penny from my earnings after I double it, because you don't have exactly that amount. You're 1 penny less than that. And so now if you try this for any other number, you plug this into the calculator, it will work for the red numbers. And so this will be the exponential equation that you have. So you'll notice whenever you're going from the green numbers, from 0.02 to 0.04 to 0.08, all of these numbers are being multiplied by 2 in an exponential. So we call this multiplicative change, and so your rate of change is actually going to be doubling from day to day. However, in your linear equation, no matter where you were between your days, you were always just simply adding 1. So these green numbers are adding 1 every single time. And so this is what's called an additive change. And so that's the biggest difference between the two, the exponential versus linear, is that in an exponential, you're going to multiply between the previous numbers to the next number. And then on linear, you're going to add from the previous days to the next number, or to get to the next number. And so now, when you're looking at linear growth versus exponential growth, some of the similarities they have is that, first of all, if you look at both of these, both of them are increasing. Okay. Another is that they both have a domain of 14 days, so each of these spanned from 0 to 14. I couldn't stop this one because the number was so high. I couldn't graph 14. It would have got too high, but I would have stopped it from 0 to 14. But in the real world, both equations, not in the math world, both equations actually have a domain of all real numbers. As far as the differences go, I talked about a few of these as I went. Under Plan 1, we have linear growth. This is adding to get to the next term. It's a straight line, and this is because the rate of change from day to day is constant. It's adding 1 every single time. In Plan 2, however, the reason this becomes exponential is you're no longer adding the same number from day to day. You're actually multiplying by a number, the same exact number in this case, 2, to get to the next number. And then you have a curved line here instead of straight, and your rate of change is actually going to double. It is no longer constant. We'll talk more about exponential growth and decay in Chapter 6, Section 1, but for right now, that is all for this page.